This is part 2 of Concepts Video 3 for the GeoSketch application. In this part we're going to be looking at a case where we have oblique AuxViews of an area in which to model some buildings, but we do not have a nadir view where we're looking straight down at that area. We mentioned in the previous video that the camera models have an arbitrary coordinate system associated with them, and that the scale is also arbitrary. So we need to introduce some real-world information in order to establish the scale. Now, if we had a orthorectified nadir image, we could do that by using the footprint, but since we don't have that, we'll have to introduce some other information such as the dimensions of a building that we approximate. This could be as coarse as counting the number of floors in a building and estimating the height of the building. Now for this exercise we've already done that process and come up with a scale factor of 5,000, and we're now going to find the z=0 plane for the coordinate system of the AuxViews, and we're going to use a geometry as our mechanism to discover that coordinate system. So use the rectangle tool, and we'll rotate around to a place where we can see the corners at the base of this rectangular building, and we'll zoom in on them. And the GeoSketch rectangle tool requires 3 points rather than just 2 because it does not make the assumption that we're working or a rectangle is parallel to the global axis system. The first 2 points establish the orientation and the length of the rectangle. The third point establishes the width, but we can't see the other corner in this view, so we use the arrow keys to rotate around to a view where we can see the other side of the building. And we can already see that we have a mismatch in that our rectangle footprint is not matching the footprint of the building, but we'll go ahead and construct some geometry. So the GeoSketch tools work such that each time you modify or create a new face, it's going to automatically texture or retexture it using the images in the AuxViews. So as we move a face, we can see the texturing on it change according to the position of that face, and we'll use that to establish the true location of this building when we see those textures converge at the corners. So in the last video we showed how if you don't set your projection plane or your AuxView working plane to the correct location, your building will be mislocated. This process will put it in its correct position according to the AuxViews. So if we pull this face towards us and line it up to the corner in the adjacent face, we'll see them start to converge such that the corners match up. And can do that same process for the 4 sides of the building and the top, and we also want to do it for the bottom of the building. When we build a primitive in GeoSketch, it puts a face on the bottom so that we can use that to pull the bottom edges of our structure to the correct elevation. So in this case again we'll use the imagery to determine where that face belongs. And once we've done that, we've used that process to establish where the coordinate system is for those AuxViews, and we'll just use the tape measure tool to measure what it came out to be. So measure from the origin over to this corner, and then we use the inferencing to measure to that projection, and we get a dimension of 22 feet 8 3/4 inches in the negative direction. Now this is where we need to remember 22 feet, and we'll just round it off to 9 inches. For the purpose of this demonstration, I'll delete that building and we'll construct it again. This time, when we use the rectangle tool, we'll hit the Alt key in order to set our altitude plane, and we'll key in negative 22 feet. And the thing that is important is that GeoSketch uses the SketchUp facility for converting measurements from one unit system to another. And in the case of units that are feet and inches, in order to key in a negative number, you have to put a negative sign both in front of the feet and in front of the inches. We'd need to put in negative 9 inches. If we did not do that, if we did not put that negative sign there, SketchUp would interpret that as negative 22 feet plus 9 inches, which would not be the correct value. So we've got our altitude plane now set to negative 22 feet 9 inches. So now we'll build that footprint of that building in the same way we did before, using the rectangle tool. And note that the scribe, or the ray that's being projected from our cursor to the modeling space, is now blue to tell us that we're working at an altitude plane, and the prompt tells us that that altitude plane is at negative 22 feet 9 inches, as well as the tooltip. So we'll put our cursor in our AuxView at the corner of the building and do the second corner, and then rotate around till we can see the third corner of that building, the footprint, and we see that it now matches the footprint of that better. We don't have to get it perfect because we'll still use that process of using the textures to fine-tune the positioning of that building. We use the push-pull tool, and we'll see when those faces, the corners, start to converge. We'll do all the top face and the sides. And in this case, we got a better fit down at the bottom because we projected those rays to the working plane that we set using the Alt key to set the altitude of the working plane. So in the next case, we're going to look at a situation where we do have a nadir image that we can use to coordinate the coordinate systems of the AuxViews to the orthorectified nadir image.